Ramya, we are live now.
So today we have with us a very special. Can you hear me?
Yes, we can.
Okay, great. Yeah. So today we have with us a very special faculty member for this webinar series, and special because she's joining us from far away. She lives in New York, but even more special because she's a friend of mine for more than 20 years now. So, very glad to introduce Charuta Joshi. As a quick background, Charuta is an alumnus of IIM Ahmedabad from the 1994 batch, after which she was in corporate India for about 10 years, almost 8 to 10 years, before she moved to New York and discovered that her passion lies in teaching mathematics. So in New York, she went through a master's in education studies with Bank Street College in New York, one of the very reputed teacher education colleges in the United States. And much later, also did a master's in teaching secondary school math from Columbia University. And for the last 14 years or so, Charuta has been teaching maths in for grade 6, grade 7, grade 8 students. More recently, Charuta also became what is called a Master Teacher Fellow with Math for America. And some of you on this call, particularly if you are enthusiasts of math, might be familiar with Maths for America. It's one of the premier organizations worldwide, and particularly in the US, bringing math teachers together and propagating math education as well as teacher development. And Charuta is a math teacher fellow, which is a status that's not easy to maintain at all. I'll just leave it at that. But with that, let me hand over to Charuta for this session, which is dedicated to maths and dedicated to everyone who loves maths and everyone who wants to teach maths. So hope you enjoy it.
Thank you so much, Ramya. Can everybody hear me? Karthik, can you? Yeah. Thank you so much.
Yes, you are audible.
Thank you.
Yeah.
Thank you for the wonderful introduction, Ramya. Ramya and I go a long way back. I also want to thank all the teachers who are here to attend the webinar. This is my first webinar, so I'm just a little bit nervous, but I think I'm going to be okay. Before we get started, I actually wanted to share my screen. But even before that, I wanted to add something else to what Ramya just said about my background. So I grew up in a really middle-class family in a small town called Ambernath, which is about an hour and a half from Mumbai. My parents both loved math a lot, and I grew up with doing a lot of mental math and developing a strong sense of numbers. I have a I'm very passionate about today's topic because I think learning about number strings will help our students and will also help us to become more flexible and develop a stronger understanding of numbers and their structure. So with that, I'm going to start my presentation. Let me see how to share the screen here. Karthik, can you confirm that you can see the screen?
Yeah, Charuta, I've added the screen to the stream. So yeah, we can
Okay.
see your screen now.
Perfect. Thank you. So today's topic is going to be number strings, and we're going to do a lot of math together in the 1 hour that we are here. Ramya has already given you a background about myself. And if you notice in the things that I have listed here, I've actually not listed my corporate India experience, because what I'm really, really proud of is my teaching experience. So I've been teaching for 10 years. First as an math specialist in an elementary school, that is a primary school. And for the past 6 years, I've been teaching middle school, both 6th and 7th grade. I was first introduced to the topic of number strings when I was in elementary school. And I have been using it now with my 6th and 7th graders too. So before we launch our topic of number strings, here are just a few expectations that I would have from all of you. I know that there are many of you out there who are watching the webinar, and it's an interesting format because I can't really see you. And most teachers, for me, definitely being in the classroom, a lot of my joy, a lot of my fulfillment comes from really students talking to me, students asking questions, students answering questions, sharing their thinking. So I'm hoping to replicate that in some form in this webinar. So what I would really like you to do is, I have the chat here on my other laptop. I would like you to ask questions. I would like you to respond to questions, write in the chat as much as possible, and I would definitely like you to take notes. Now, one ask I have of you is, we're going to do a lot of math together, and I would really like you to try the problems in your head. So we're going to do a lot of mental math together. This is what we are asking our students to do. And for some of us, it's not difficult. But for some of us, it's a little nerve-wracking to do a lot of mental math to solve difficult problems. But if that's what we are asking our students to do, I think it's good for us to practice it ourselves too. What I hope that you will take away from this webinar is a set of sample problems that you can try out in your classroom, and a structure, a framework for a method for how to do number strings in your classroom. Again, this is a routine. This is a process that comes only out of practice. So I'm hoping that the more you practice, the more capable you will become in doing number strings. So now let's see what are, let's go through today's agenda. So I'm going to explain what number strings are. I will watch a bunch of small little videos so that we can analyze the videos. We'll see a teacher actually doing number strings in her 4th grade classroom. Then we'll do a bunch of number string practice together. Do some reflection as to what was difficult, what is it that we liked in number strings, and then we'll practice some more number strings together. And I'm happy to answer any questions that you have along the way. Yeah. So what are number strings? Take a moment to read this page. So number strings are a set of related math problems. It's a set of problems. It's not one problem in isolation. It's a set of problems, and the problems are all linked to each other. That's why it's like a string. It's like a chain of beads where each bead is a problem, and they're attached to each other in a chain. And they're crafted to support our students to construct big ideas about mathematics and build their own strategies. I think the word crafted is very deliberately used, because crafted means they are very thoughtfully put together so that they all make sense, so that one problem builds on another problem. And using number strings, students can get a better understanding of numbers and about operations. And the best thing is that they build their own strategies and use other students' strategies and build off them to create their own understanding. I'm a big proponent of students creating their own strategy. That's not how I grew up in India. In India, I was told what to do, but at home, there was a lot of push for mental math and developing my own understanding. And I think that made me a much stronger mathematician. So before we start on our videos, what I would like to do is give you a small problem, like a small sample, so that you understand what really number string means. So bear with me for a moment. I am going to set up my tablet. In the meantime, can one of you write a comment to me so that I know that I can see your comments? Yeah. Okay. Okay. So, okay. I don't see people's comments. Can one of you write a comment in the, oh, maybe I should be going to live comments. Oh, wow. Okay, perfect. Thank you. So I was in the, okay. So, and can you see my board and that I am scribbling on this board? I taught elementary. Actually, I taught I taught elementary from 2nd to 4th standard, 2nd to 5th standard. So can you see my screen? Yep. Deepa from my source says that yes, she can see my screen. Perfect. So here is a small problem that we can start off with. And I would pose this to, I don't know, it's 2nd grade, 3rd grade. I would say somewhere between 2nd standard and 3rd standard. Yeah. So we start off with, say, 50 plus 4. Small enough. This is called a starter problem. It's an opening problem. Many kids would be able to do this. And we say, okay, that's 54. You ask students to say, how did you know that was 54? And you would model this on, say, okay, I know that if I start off with, say, 4, and then I add 50 to it, I will reach 54. Okay, simple enough. And then you build on that and then say, okay, so what is 49 plus 4? And again, students are going to share their strategies and they say, okay, I know that 49 is 1 less than 50. So 49 plus 4 is going to be 1 less than 50 plus 4. So it's going to be 53. Again, you have built on the earlier problem to say, okay, 50 plus 4 is pretty simple. I'm going to use that to figure out 49 plus 4. Then you move on to saying, okay, if 49 plus 4 is 53, how much is 49 plus 24? And again, the right answer in this case is not that important. I know we all grew up in India believing that what is important is the correct answer because math is all about right and wrong. But in this case, what is really important is how students are thinking and how students are building off each other's strategies. So again, we would say, okay, I know that 49 plus 24 is just 20 more than 53. So I'm just going to add 20 more. And that will lead me to 73. Then I'm going to make it a little more difficult and then say, okay, so if I know 149 plus 20, if I know 49 plus 24 is 73, how much is 149 plus 24? Cool. I see that some people are already checking strategies. Yep, check the strategy and not the answer. Absolutely. So how do you think kids would think about 149 plus 24? and why. Again, let's not focus on the answer, but I want you to really write about what do you think kids are going to say when you ask them how much is 149 plus 24. Yeah, plus 100. And Mahi says that it is plus 100, so you're just going to add 100. Yep. So it's plus 100 and you have reached 173. I'm sure that some of you already teach this way. Maybe many of you teach this way, and that's really great. And then now we're going to make it a little more complicated and say, okay, if I know 149 plus 24 is 173, how much is 149 plus 324? Right? And say, okay, 149, we already know. And how much did I add? So how do you think kids are going to solve this problem? So I would add 300, absolutely. So I have Sri Devi who says that we're going to add 300 and we're going to add 300 more, and that's going to be 473. Now, I know that this looks really simple, but you're showing to the students I can start at 50 plus 4 and get to something that's not very familiar, and that's much larger, and get to 149 plus 324. So that was a quick intro problem to number strings. So let's watch some videos together. And as you watch the videos, I want you to make a lot of notes, because I'm going to ask you to share your noticings as you're watching the video. So here we go. Hold on. Okay. So there is a website called numberstrings.com, very conveniently mentioned as numberstrings.com. So let's see. This is the first segment. I'm going to start at 40 seconds. So you're going to watch a bunch of videos. I want you to tell me, what do you notice as you watch this video? Yeah. So let's say, yep, here we go.
We talked about multiplication on the number line, right? And we had two strategies that I think you might want to keep in your mind for today. One thing was that Sam's strategy was to think about equivalence. He thought about 8 times 3 as equal to 6 times 4. Equivalence. Can we find another problem that helps us solve a problem in multiplication? Another thing that will help you today is what? Step by step. What? Dakota's strategy. Oh, piece by piece. That was an inch.
I thought it was mine.
Yeah, that was cool. Oh, maybe it was both of your ideas. Good ideas almost always come from 2 people or 3 people at once in the history of the world. Dakota's strategy was thinking about jumps on a number line, and she doubled the jumps. Okay? So that might help you today. Our first problem is 2 times 50. Give me a thumb. What do you call it? Keith, what'd you get? 100. And how did you get that?
Charuta, is there some way to increase the volume a little bit?
Sure.
Yeah. And also, if you could make it full screen. I guess it's already full screen.
It is full screen. I'm going to play it and then pause it in 10 seconds, and you tell me if the volume is any better. Yeah?
Sure.
All right, let me draw a picture of it. So if you remember some of the work I did with the number line.
Is that any better, Karthik?
Yeah, it's possible to, I mean, just increase it to the max possible.
I have increased it to the max possible.
Okay, sure. Then that should be fine.
Oh, it's not very audible, is it?
Yeah, there's a bit of a lag. There's a bit of a lag.
Okay, but can you hear after the lag or not really?
Also, I think the viewers are saying that what is being written on the board, that's not visible.
Yeah, that's because it's she'll start. It's not visible even to me. It will then start. She'll start writing more. Yeah? And I will start repeating what she's saying. Yeah.
done before, you can think, how
Sure,
am I gonna
sure.
draw this? If this is 0, you take one jump of 50,
And then another.
and then another jump of 50, and we get to 100. Right? Okay. Now the second problem is 4 times 25. Give me a thumb when you have it. 4 times 25. What did you get?
100.
And how did you get that?
Because if you
Okay, I think a bunch of people. Yeah, I will share the link of the video here. Give me one moment. Okay, so I think when we tried it during test run, it kind of worked, but it's not working here. Let me share the. How do I share it? Okay. Karthik, is it possible to share that link with people?
Sure. Sure. I'll do that. Yeah.
Okay. So looks like it's not very visible to people what she is doing. And so I'm not going to spend too much time on that. Let me go back to my. Okay. So one of the most important things, so let me just jump into the process myself, because if you're not able to watch the video, you can watch the video at numberstrings.com. In that, there is a specific video for 4th graders where she does division using 4th grade. Now, here are some of the strategies that you will see that she uses. Firstly, the teacher presents the problem one at a time, not all the problems together. A really, really important thing for her is giving students plenty of time to think. If you go to the 3rd video, and I hope that you do on your own, and you go to minute 548, yeah, the 3rd video, minute 548, you will notice that she waits for, let me see, 12 plus 36, 38 seconds, which is a long time in a classroom, standing quietly, telling students that, nope, we're not sharing our strategies yet. I am going to give everybody some time to think. So not calling on the first person who raises their hand, but telling students that I'm going to give you some time to think is a really, really important part of this. So at 5, you can see this at 5:48 in period in video 3. Yeah. You'll also notice when you watch the video that students solve these problems mentally. They don't even have paper and pencil in their hand. They do it in their head, and then they talk about it, and they share their strategies. So students are given a chance to articulate what strategy they used in their head. And what does a teacher do? When you watch this video, you'll notice that as the students are sharing the strategies, the teacher models the strategies on the board. Now, teacher doesn't show what is in her mind. What is in her mind? Well, you have a bunch of things that there is a way that you would do the problem. And there is a bunch of models that you would have. But what is really important is the way that students thought about it. And if a student says something, then you model that strategy on the board. So that's an important element of number strings. And the last important part in this is facilitating the conversation among students. Again, if you go to, so I'm going to actually put in your what are important places where you can see some of these things. If you go to part 3 of video and go to minute 245, she asks them to do a turn and talk. So what is a turn and talk? A turn and talk is where you turn to the person next to you and share your strategies. That gives a lot of, everybody wants to talk, but when there's a teacher to student conversation, only one person is able to talk at one time. But when you have students turning to each other and talking, now half your students are talking. Of course, it's a little chaotic, and you have to go through the norms of how do we talk softly and how do we talk productively. But a turn and talk is really powerful for students to exchange ideas. And what do you do in the meantime when turn and talk is going on? You circulate, if it's possible, amongst the students and listen to what they are saying. And then you say, oh, I heard Ram saying that we can do this way, and do you guys agree with it? And then show it on the board. Yeah. I know that there are a lot of constraints in how you are supposed to be teaching, but we teachers are creative. We have a lot of constraints. We have a test at the end of the year, and we have a lot of constraints, right? But we know how to be creative. Nobody's in our classroom 24/7. So we can figure out ways, and number strings, you end up doing, say, about 5 minutes, 3 times a week. Yeah. And it's really powerful strategy. So I don't want to spend too much time, since you cannot watch the videos. I'm going to strongly urge you to watch the videos so that you can get a better sense of how do we do number strings in the classroom. So what are we going to do now? We are actually going to do some problems together. Now, when we do the problems together, remember, you have a paper and a pencil with you. But that paper and pencil is only to write down your answer, if you have to. I do not want you to send me the answers. I want you to really send in your chat, how would you do the problem? And I'm hopefully, if possible, I'm going to build off what people say about how they'll do the problem to actually show it on the board. So let's see what we have here. Let's look at the next. So I'm going to do a bunch of multiplication problems. I'll start off with 3rd grade. When I say grade, it means standards. I moved here 15 years ago, and to fit in here, I have to use the words that I used here. So grade, standard, it means the same thing. So I want you to share how you thought about it and not necessarily the answer. Yeah. So let's look at simple multiplication. In what grade do you do multiplication tables? Can one of you tell me? If I remember, multiplication tables would be about 2nd grade or so. So you can start introducing this in 2nd standard. Yeah. 3rd standard? Yeah, absolutely. Gurpreet. That's when we introduce multiplication here. So let's start with, again, something very, very simple. Yeah. You would say, okay, 2 times 3 equals, and then some student is going to say, okay, 2 times 3 equals 6. Yeah. Again, there is nothing very phenomenal about 2 times 3 equals 6. Then you would say, okay, what is 3 times 3? Oh, that's 9. And what's 10 times 3? Now, somewhere in 1st and 2nd grade, you would learn that 10 times something, you put a 0 in the end. So 10 times 3 is going to be 30. Yeah, absolutely. So Sajna said that 2 times 3, students are going to think about it as 3 plus 3. Now, in multiplication, we're going to start off with thinking about it additively, but pretty soon we're going to think about it multiplicatively, and I'm going to show you how. Because students are used to, even here we do repeated addition, but really you want them to think about multiplication. So we've got 2 times 3, 3 times 3, and 10 times 3. Okay, so how would you do 4 times 3? You could do 4 times 3 by doing 3 plus 3 plus 3 plus 3. But is there something that will help you here to actually figure out 4 times 3? Is there something already here that can help you to do 4 times 3? And I'm still waiting. You could do 9 plus 3, absolutely. You could do 9 plus 3. That is, you're already using 3 times 3 is 9 to figure out 4 times 3. Or you could do 2 times 2 times 3. So you could say so I have done right now 3 plus 3. Or I can say, if I have this as 2 times 3, I don't know if you have used the area model to show multiplication. That is how I taught multiplication in 3rd grade. So this is 2 times 3. I'm going to show 4 times 3. Or I'm just going to double it. And now this is 4 times 3. So you're going to show that strategy model that, okay, 4 times 3, if 2 times 3 is 6, then 4 times 3 is just going to be double of that. And that's going to be 12. Yep, absolutely. 2 times 2 times 3. Now, therefore, how much is 8 times 3? How can I use my knowledge here to figure out what is 8 times 3? I am still waiting. Again, I don't, of course, 3 plus 3 plus 3 plus 3 plus 3 plus 3 plus 3, I think I said it 8 times, is an answer. But we really want them to think about, okay, how can I use what I have here? It's 12 times 2. I see somebody writing 12 times 2 and then say, okay, so I have 8 times 3. I know that this is 4 times 3. So I'm going to double that. And that's going to be 8 times 3. Yeah. And so 8 times 3 is just going to be, if this is times 2, then this is going to be times 2. And that's going to be 24. Yep, double of 4 times 3, absolutely. And then what's 6 times 3? Okay, so this brings us to one of the, so I know there might be a different way in how you write 2 times 3. So the way we think about 2 times 3 in the US, and then you have to decide how you do it in India, is 2 times 3 means 3 taken 2 times. So you have 3 taken 2 times. Yeah? What do we do about 6 times 3? Absolutely, we do double of, and then you would make a model here, show 3 times 3 and show double of that, and that's 18. Because it's double of 3 times 3. Okay. And then how do we do 5 times 3? I can see that there is a bit of a lag here. So how do we do 5 times 3? Half of times 10 times 3. Again, I am grabbing onto the first answer that I see here because in the interest of time, I'm going to move on. But you would say, okay, so I have 10 times 3 is this. 10 times 3 is this. I am going to take only half of it, and that's going to be 5 times 3. So I want to take this away, and half of 30 is 15. Moving on to a trickier one, right? Because 9 and 7 are nobody's favorites. So what is 9 times 3? Again, I know that some of you are saying that 5 times 3 would be 5 plus 5 plus 5, but you have to be really consistent in multiplication. And the way I'm treating this multiplication is that 5 times 3 means 3 taken 5 times. Yeah. So what is 9 times 3? So triple of 3 times 3? Absolutely. So you can think of it as triple of 3 times 3. What else can I do? 10 times 3 minus 3? Yeah, I can say, so I have 2 different ideas already from 2 different students. I can say it is 3 times 3, triple of that. Or I can say, oh, I already know 10 times 3. Then 9 times 3 must be 1 3 less. And so it must be 27. So whichever way you go, you will get to 27. If you're beginners, then 10 times 3 minus 1 times 3 might be a simpler way to think about it, because you might not know what 9 times 3 is, right? So this is what you would do in 3rd grade. So let's talk about 7 times 3. How would you do 7 times 3? Because 7 is a nasty number for multiplication tables. And I know eventually we want our students to memorize a multiplication table, but we want them to start off with saying, okay, I can figure this out even if I haven't memorized it. So what do you think about 7 times 3? You could do 10 times 3 minus 3 times 3. Absolutely. What else can you do? Thank you, Gurpreet. 8 times 3 minus 3. Wonderful. Absolutely. So you could do 7 times 3 would be, I have got 2 different ideas. 10 times 3 minus 3 times 3. For me, 6 times 3 plus 3. And for me, a classic has been for teaching kids multiplication. For some reason, kids seem to know what is 5 times anything. They just seem to know it. And you have to leverage that to say, okay, if 5 times 3 is 15, and you know 2 times 3 is 6, then 7 times 3 is just going to be 5 times 3 plus 2 times 3. I'm going to talk less. Here we go. So here is how you would model. Yeah. Here is how you would model. So this is 2 times 3, and this is 5 times 3. Here is how you would model 10 times 3. Take away 3 times 3. Eventually, it's not just what you think, it is how our kids think, and you have to build off that strategy. Because for different people, different things appeal to them. Some people just know 8 because they know I can get to 8 by doubling 2 and then doubling 2 again. So you see, now we have given them a good grounding for the multiplication tables. If they're ever stuck, they know how to figure out things. You know that using just 2, 3, and 10, I can figure out the rest of it by doing some mental math in my head. Yeah? So this is in 3rd grade. You started small. Let's see what we could do as next step. Okay. So I'm going to erase this. I'm hoping that you guys are taking notes. I am going to make an infographic with all these problems. So just in case you are not able to write this down, that's fine, because I will send you an infographic with this problem. Yep. Okay, so here we go. Let's move on to, I promised you we'll do lots of problems, and we will. Okay, so here is another problem. Starting off with 2 times 3, our favorite. Yep, that's 3 times 3 and 10 times 3. Those are kind of like our fundamental. Then we say those are like, I would think of these as your starting problems. How can I use this to get to 12 times 3? Any ideas? Now we are going into 4th grade. We are going into double-digit multiplication, yeah, or 3rd grade, whatever you're teaching at whatever point. Yep. So what is 12 times 3? Again, don't want you to memorize it because we're pretty soon going into much bigger problems. So 12 times 3, anybody? Absolutely. It's 10 times 3 plus 2 times 3. I already know 10 times 3 is 30 and 2 times 3 is, so I'm going to write it here. 10 times 3 plus 2 times 3. I don't know if you are realizing what property of mathematics you're already using here, and you're showing it to the kids. You might choose to or not choose to talk about it explicitly, but you're definitely using a property of mathematics. So 10 times, so that's 36. Okay. 5 times 3, we already figured out, that's 15. Yeah. And we already figured out 7 times 3 is 21. How can I figure out 30 times 3? Yeah, absolutely, Sridevi. I see Sridevi is talking about distributive property, and that's what we are doing. We're saying 10 times 3 plus 2 times 3. As you go, when you start introducing this distributive property, that is when you will show them, oh, that is the same as saying 10 plus 2, the whole thing times 3. And you would do it in your modeling, because distributive property is best modeled by area model. Even when you go into algebra and you're doing x plus 3 times x minus 1 in parentheses, the best way for students to really understand how it works is by doing an area model. Yep. So you would say, okay, this is 2 times 3, and then I'm going to do 10 times 3, and that's going to be 6 plus 30, and that is 36. Yep. So now I have 30 times 3. How much do you think is 30 times 3? And how do I, that's 10 times 3 plus 10 times 3 plus 10 times 3. Absolutely. So Bindu says that it's 3 times whatever I got for 10 times 3. Yeah. So I know 3 times 3 is 9. So 3 times 30 must be 90. What about 15 times 3? How many different ways can you figure out 15 times 3? What can you do to figure out 15 times 3? So I absolutely do not recommend what I'm going to do right now, but I'm going to, oh, I got somebody. But at some points, I'm going to move on because we have about, I think, 15-20 minutes, and I have a lot of problems that I want to show you. Yeah. So Danish, I don't know if I'm saying your name correctly, but it is half of 30 times 3. So half of 30 times 3 is 45. Yeah. How do we do 27 times 3? You already noticed we are going into problems that most kids will need a paper and pencil to do it. Many adults might also need paper and pencil to do it. So what do you do for 27 times 3? Oh, for 15 times 3, I got another strategy. We got 10 times 3 plus 5 times 3. Absolutely. You see, two different people have two different strategies. So what do we do for 27 times 3? Again, we are telling the kids that can you use the problems that you already see to come to 27 times 3? You've got 12 times 3. Absolutely. So you have 12 times 3 plus 15 times 3. That definitely is one way. And another way, brilliant, would be 30 times 3 minus 3 times 3. What a beautiful, beautiful example of the distributive property, right? Because you're showing them that distributive property is not some esoteric property that you use while doing algebra. It's a property that you use for doing mental math for difficult multiplication. Yeah. So, and that's 81. And what is 17 times 3? I got one more answer for 27 times 3. Somebody said 20 times 3 plus 7 times 3. Absolutely. And somebody else said 3 times 9, the whole thing times 3. Beautiful again. So what about 17 times 3? So I'm going to move on. 10 times 3 plus 7 times 3. Absolutely. And 10 times 3 is 30. 7 times 3 is 21. And 17 times 3 is 51. Now, what about 42 times 3? One last one before we move on to a little more difficult multiplication problems. So what do you think about, 17 times 3? I've got Ali Kumar who says 20 times 3 minus 3 times 3. Beautiful. So she says 20 times 3 minus 3 times 3. Okay. So is there another way using the distributive property? I would think that multiplication and distributive property really go closely hand in hand. So I don't know if there is another way, but if you can think of, that'll be pretty cool. So, I have Sajna who says 30 times 3 plus 12 times 3. Yeah, we can do 30 times 3, absolutely, plus 12 times 3. What else could we do? For 42, we could also do, let me see, 27 times 3 plus 15 times 3. Yeah, so I could add 81 plus 45, and or I like this one much better. 30 times 3 is 90 plus this is, and therefore it's 126. Yeah, absolutely. So I am going to move on to slightly more difficult problem. So let's say one more multiplication problem, and then I'm going to ask you for reflections. Very nice, guys. I love how you are participating. Thank you so much. Yep. Okay, so let's look at, we have 2 times 10 is 18. 2 times 8 is, 2 times 10 is not 18, it's 20. 2 times 8 is 16. So 2 times 18 is 36. Again, what you've really said is 10 times 2 is 20. 10 times 8, 10 times, sorry. 10 times 2 is 20, and 8 times 2 is 16. So 18 times 2 is 36. And then you talk about how, because of the area model, multiplication is commutative. Yeah, because if I have this rectangle like this of 2 times 10, I can switch it around and make it 10 times 2 and vice versa. So now we're going to use that to say, okay, how much is 4 times 18? 4 times 18 is just going to be double of this. And so that would be 72. Again, you're pushing them to do it in their head. You want them to do 36 plus 36 in their head. And you really want them to keep the paper and pencil away. And you want them to say, okay, how did you do 36 plus 36? Oh, I did 30 plus 30 is 60, and 6 plus 6 is 12, and I put it together. That's 72. Or somebody else might say that, oh, I added 36 plus 30, that's 66, and I added 6 more. Yeah. Then you go into, I'm going to rush through this a little bit because I have some other beautiful ones to share. 10 times 18 is 180. So 20 times 18 must be double of that. That's 360. And we know 5 times 18. So I don't know if you ever introduced to kids about how you can find 5 times anything. For, I mean, 5 times 9 we know is 45. So that's simple. But 5 times, say you wanted to find 5 times 36. Here is what I tell kids, that 5 times 6 is basically 10 times 36 is 360, and 5 times 36 is half of that, that's 180. Yep. So I always go with, what do I know? How can I use that to figure out what I don't know? So 5 times 18 is basically half of this, so that's 90. Then we move on to 50 times 18. And 50 times 18 would be 10 times this, so that's 900. You see, I'm moving on a little faster right now, not because that's what you do in your classroom, but in the interest of time, I'm just moving on a little faster because I definitely want to show you percents. Yeah. 52 times 18. Oh, that's 50 times 18 plus 2 times 18. This, and that's 936. You see the kind of math that we are able to do just in our head. And then you would say, okay, 9 times 18. Oh, 9 times 18. I could take 72 and 90 together because that's 5 times 18. Absolutely. 162. And then I could do 19 times 18. And you will have various strategies. You could do 10 plus 9, or you could do 20 minus 1, whichever strategy works for you. So let's say 10 plus 9, 180 plus 162. 100, 140, that's 340, and we got 342. Then you go into 45 times 18. How would you do 45 times 18? Wow, 45 times 18. This is one of them that I'm going to wait for you to tell me. How would you do 45 times 18? 360 minus 18. 360 is 20 times 18. Yeah, that is for 19 times 18. Beautiful. 5 times 9 times 18. So you're saying I will take 9 times 18 and multiply that by 5. And to multiply that by 5, I can say, okay, 1620 is 10 times 18. 10 times 5 times 18. Oh, I mixed myself up. So somebody said 5 times 9 times 18 and 5 times 162. Well, I have my favorite strategy. 10 times 18 is 1620. So 5 times 18 must be half of that. That's 810. Yep. Or I could do absolutely 50 times 18 minus 5 times 18. Priyanka, did somebody wanted to jump in?
Yeah, hi. Sorry to jump in, Charuta. Just a quick time check. It's 5:51 now.
Yeah.
An announcement for the viewers. We've shared a link in the comment section. It's basically a link to the feedback form for the session. I would request all of you to fill in the feedback form. Please make sure that you've entered your name and contact details. This is for us to create a record of your participation and mail it to you. So I'll just request all of you to take a couple of minutes and then fill in the feedback form at the earliest.
So should I wait, Karthik?
Yeah, that'll be great if you could wait for a couple of minutes. Let's just give everyone a couple of minutes to fill this. It's a very short form, and we
Absolutely.
can start after that again. Yeah.
Yeah. So I think people are wanting. Some people are saying they can't see the link.
Yeah, I've pasted it again there.
Okay. Some people are still saying, please send link, can't see the link. Karthik, you will tell me when I can start again?
Sure.
I'm going to delete this.
I think a lot of teachers have already submitted it, so I think we're good to start again.
Okay. So
Yeah.
I think we have only 6 minutes more, right, Karthik?
Yeah, it's 5:54. We've around 6 minutes more. But if you feel that, if everyone's fine with it, we could extend it by say 10-15 minutes more, if that works for everyone.
Yeah, I mean, I want to share two more sets of problems and then quickly go over what was difficult and what did they like about this. Yeah.
Sure.
So if I will go over this for sure, and then I will ask students for my teachers for reflection, and then I will move on to the other problem. If teachers want to drop off, that's fine then. Yeah.
Sure.
So this is my absolute favorite topic. Yeah, percents, and this lends really well for number strings. So we start off with something simple. 10%, 100% is 40. How can I figure out all of these scary things? Yeah. And I'm going to go, so how do we find 10% of 40? Oh, 10% is just 1/10, right? So 10% is 4. I'm going to tell you what students typically say to me, and I strongly recommend that that's not how you would do in the classroom. You would wait for students to share their strategies. And then somebody would say, okay, 10% is 4, so 5% is 2 because it's half of 10%. And 30% is just 3 times 10%, so that's 12. 80% is just 8 times 10%, and so 8 times 4 is 32. Again, all we are doing is using the distributive property in various different ways. In this case, actually, we're not using the distributive property. We are using the associative property. Here, we are going to use the distributive property and say, okay, if I have 85%, then I am just going to add 80% plus 5%, and that's 34. And that's literally how my kids do percents in their head. They start from like, whoa, we need to multiply 0.85 times 40. And I was like, can you do that in your head? No, let's figure out a system where we can do a lot of the math in our head. Yeah? And then 1%, we know we just divide by 100 because 100% is 40. So that's 0.4. 50% is powerful because you can use 50% to get to 25%. If 100% is 40, then 50% is half of that, that's 20. 25% is half of 20, so that's 10. And 75% is basically 50% and 25% put together. And that would be 30. Again, some kids might think of it differently. Some kids might think, oh, I know 70% is 28, plus 5 more percent is 2. So 28 plus 2 is 30. 12 and a half is very interesting because there are various different, first kids look at it puzzled and say, what? What do you mean 12 and a half? Why are you throwing such ugly numbers at us? And then somebody will say, oh, 12 and a half is just half of 25. So 12.5% must be 5. And that's something they pick over time. You do this 5 times and you're like, oh, 12.5 is just half of, absolutely. Somebody here puts in 5. And somebody writes in here 75% is 100% minus 25%. Again, a classic way that kids talk about it. 75% is 100 minus 25, because that's a beautiful way to think about it, that 3/4 is just a whole minus 1/4. Then what about 2.5%? So again, kids think of it in different ways. Here are the 2 ways that I've seen kids think of it. 2.5 is just half of 5. So 2.5% must be 1. And the other way kids think of it is 25% is 10. 2.5% is 1/10 of that. So I just move the decimal point over and that's 1/10. And so on and so forth. You can find 110% by adding 100% plus 10%. Each of these things you can do by taking what's being given earlier. So I'm going to pause at this stage. I want you to reflect on what is it that you like about this? What is it that you find difficult? So I'm waiting for you to write or think and then write, what is it that you like? And can you, if possible, be as specific as you can be. What is it that you like about this? And what is it that you find difficult? Many ways to come to the same answer. That's a big part of it, Rima. It's interesting. Can you, aha, I love this. And I'm going to include that, from going from the known to the unknown. That's a fundamental part of mathematics, to go from the known to unknown. Can I use whatever I know in math so far to figure out things that I don't know? Yeah. Instead of one difficult problem. So here are some of the things that people are writing. You go from known to unknown. you're driven by children's responses, there are many strategies to come to the same answer or to solve the same problem. Instead of giving, Ashwin says that instead of giving one difficult problem, we solve many simpler problems and gives us a sense of achievement and practice. Absolutely. It will help children motivate. What is difficult about for you? What do you think is going to be difficult for you to implement this? Squeeze the mind by game. Yeah, absolutely. Allowing kids to think. Absolutely. With this math, with this number strings, kids are not bored because everybody is, there's a tiny little bit of competitiveness that kids come up with when you start doing number strings, which is good. You don't want to make it too competitive, but kids want to think and want to share their strategies. Time constraints, I absolutely agree with you. It is going to be difficult in the beginning. I want to say that, I don't know if we can do some problems together again, but this will come with practice. Mental math comes with practice. Modeling comes with practice. And doing number strings comes with practice. Because as you remember, number strings are crafted in a way, they're put together in a way so that you start with simple problems and you build on to more and more and more difficult problems. Now, modeling is a great way for all students to understand why the math works. I think it's all, somebody's talked about kids with special needs. I think it's also a great way for kids who can think visually to understand what is the math behind it. And for some kids who have issues with memory, I have some kids who have short-term memory issues. That means what they just said, they can't remember it right away. Yeah. So for those kids, you give them an option to say, okay, whatever you use, can you put it down? Yeah. So you always make exceptions for kids who need it. You want to empower them. You don't want to weaken them. So if some kid says, I absolutely cannot keep all these numbers in my head, you say, that's fine. Why don't you start with just writing down those numbers on paper so that you can forget about them because they are now on paper. Yeah. Again, it's not a rigid recipe. It's not something, oh, this is how you have to do it. It's something that you have to try. It is flexible. It is best if you come up with it suitable for what is your class, for your classroom. So at this point, I know a bunch of you need to drop off because I want to respect that it's already 8:33. I want to go over one more problem in fractions. And I think this is a very powerful way. So here is, I know some of you are asking my email address. What I'm going to do is I'm going to put together, or maybe I can just write it here or not here. Priyanka, can you share my email address? It's charutanjoshi@gmail.com. charutanjoshi@gmail.com. So I want to share one last strategy because I do that even in 7th grade. So let me see. I do percents in 7th grade using this. Yeah. So if somebody were, I use this a lot with rates. Somebody was to tell you that 3/4 kilos is 60 rupees. You want to eventually get to, in your mind, you know, you want to eventually get to 1 1/5 kilos. So you say, okay, how do I do this? And it's been amazing that nobody's, okay, if you have a calculator and you can just say, I know how many times 3/4 goes into 1/5, 1 1/5, I could just do 1 1/5 divided by 3/4 and multiply that same number by here. Yeah. But you really want to think about it very slowly. So here is one way you can think about it. If I know 3/4, I can figure out 1/4. And that is just 1/3. So if this is 3/4. Then, and all of this together is 60. Then how much is just one part? One part is just 20. Absolutely. Well, not 60 divided by 4, 60 divided by 3. Because we have taken only 3 parts. So if 3 parts of something is 60, then 1 part of something must be 20. If 1/4 is 20, then I can find 1 kilo. And again, some kids will say that I'll just multiply that by 4. And some kids will say, I will add 3/4 and 1/4 together. Whatever they say is what you show in your model. You don't show what's in your head, you show whatever they say. So they add 3/4 plus 1/4, that's 1 kilo. So 60 plus 20 is 80 rupees. Yep. Then how do I find 1/5? Oh, I'm going to divide 80 by 5. Again, if you remember my strategy for multiplying 5 times something, the same thing works for 80 divided by 5. Here is what I do. I do 80 divided by 10 is 8. Oh, but I actually wanted to divide by 5. So 80 divided by 5 must be double of that. That's 16. Yep. So 1/5 is 16. So 1 and 1/5 must be 96. So I am going to stop at this stage. I will send out an infographic which has all these different problems that we have used. I will give you my email address. I will give you a short summary of what number strings are and what is the process. And I have a YouTube channel called Math Dudette, and I'll put that in the infographic. So right now, I'm just going to wait for any questions that people might have. Otherwise, I really, really, really want to thank you for attending this session and for being so responsive in in answering the questions. Thank you so much, and all the best for trying this out in your classroom, and also all the best for remote learning, because I just went through 3 months of remote learning and it was an amazing experience. And you are just starting school, so all the best to you for starting remote learning. Thank you. So at this stage, I'll just wait for a few minutes to see if people have any questions. Yeah. Karthik, over to you.
Thank you, Charuta. Thanks a lot. I was just going through the comments, and there were almost, I think, 400 of us who attended the session today, and everyone, I'm sure, absolutely loved the session. I think we've also started getting emails about teachers thanking us for the session and saying how well they enjoyed it. So
Thank you so much,
as
Karthik.
Charuta said, as Shalta said, we'll just wait for say a couple of more minutes to see if people have any questions. And the video is going to be available on our YouTube channel. So you can always come back and watch this. And yes, Niharika Khosla is asking, kindly tell your YouTube channel. So it's
Yeah,
Math Dudette. And yeah.
I'm just going to post the link in here so that it's
Sure.
easier for people. Yeah.
Sure.
And I also post my email address.
Yeah. Someone saying even as a language teacher, they enjoyed it.
Thank you. How do I post something? Can I post it in the private chat, and can you then post it in the live comments?
I'll post it in the live comments. Yes.
Okay. So I've just posted my YouTube channel. It's called Math Dudette. And my email address is charutajoshi@gmail.com. And I posted that too. Ooh, I love somebody said that we can verify the answers by using one more method. I love that idea. I'm also just going for over the comments. Somebody says they want the right method to approach decimal multiplication and division. Ooh, okay. I just think of decimal multiplication as do the multiplication, forget about the decimal, and then just put in as many decimal places. I don't know. Of course, I explain to them why it works. Yeah, so somebody is asking for a short note which is a quick recap, and I'm going to give an infographic, a note, which has everything that we have covered in this session.
Sure, we'll send that as an email to all the teachers who've registered for the session.
Perfect.
Yeah.
So, Karthik, you let me know whenever you want me to leave the studio. Yeah.
Sure. I think I was just I'm just scrolling through the comments. I can't see any new questions.
Mm-hmm.
I think that's it. We'll call today then. So thank you once again, Charuta. Thanks a lot for agreeing to do this. And as Priyanka also mentioned in the comments, we have our online course for course cum certification for online teaching starting this Saturday. And Charuta is one of the faculty members. The registrations are open on my center, m.center.org from your mobile browser. So if you are interested to know more details about the course, what all it cover, please do that. We'll be closing the registrations tomorrow, so if you would want to register, please do that before midnight tomorrow.
Okay. Thank you. A pleasure being here, Karthik, and thank you for inviting me. It was a great opportunity for me. Thank you.
Welcome, Charles. Thanks a lot.
Okay.
Thank
Bye.
you. Bye, everyone. Bye.